Hello students, welcome back to our class. We were dealing with the lesson atomic structure and chemical bonding. In this we have covered about the structure of atom and that we know it is made up of subatomic particles, electrons, protons and neutrons. We have already dealt with its discovery that about subatomic particles and characteristics of these electrons, protons and neutrons. And discovery of nucleus also we have discussed. About Rutherford's alpha scattering experiment we have discussed. Now we'll move ahead in the session with discussing in general the structure of atom. About Bohr's atomic model also we have discussed, right? So from there we will move ahead in the session. That is, the atom is built up of number of subatomic particles. The three subatomic particles of great importance in understanding the structure of atom are electrons, protons and neutrons. So these are the general characteristics. That electrons, the symbol charge is known as -1 E0 or simply E minus also you can write. So it has -1 charge. Its mass is 1 by 1840, that is 9.1 into 10 power minus 28 grams. Or for proton, it is represented as in this manner of simply P plus. It has charge equal in magnitude but opposite, like +1 in terms of electrons, right? Its mass is 1 only and 1.6 into 10 power minus 24 gram. Neutron has no charge in it, but it has 1 mass, which is similar to the protonic mass only. If we talk about now that there are two structural parts of an atom, that is known as the nucleus and the empty space in which imaginary path or known as orbits are present. So this is a general representation which says that this central part is the nucleus and these concentric rings are your imaginary paths, or you call them orbits or you call them shells also. Electrons are found in these orbits only. Nucleus. The protons and neutrons, they collectively called as nucleons and they contribute towards their sum, contribute towards the atomic mass of the element or particular atom. They are found in central part or nucleus. Orbits are what? These are imaginary path where electrons revolve around the nucleus of the atom. There is a simple definition that also you need to remember. An atom of an element has its own characteristic number of protons in its nucleus, which distinguishes it from the atoms of other elements. For example, they are simply saying that atoms will have different protons in terms of different examples, right? For example, when we are saying oxygen, so it has 8 atomic number, it has 8 protons. We will discuss how we calculate that also. Nitrogen is 7, it has 7 protons. So it is protons, electrons and neutrons are unique for a particular element. It is not going to be same. This characteristic number, that is number of protons, is known as the atomic number of the element, which is represented by Z. The atomic number is therefore equal to the number of electrons in the atom also. When we are saying it is equal to number of protons total present in the atom, then because protons are only in opposite sign to electrons but have same magnitude, so we can also say that atomic number is the total number of electrons in an atom as well. So that constitutes the definition of an atomic number, that is the total number of electrons or total number of protons in an atom. The number of protons gives the total positive charge present in the nucleus of an atom. So here the definition is that the atomic number of an element is the number of protons present in the nucleus, electrons present in the neutral atom and positive charge in the nucleus of an atom. Atomic number is represented in this manner where you simply write it as X and superscript A and subscript Z, where the superscript A represents the mass number and the subscript Z represents the atomic number. Atomic number itself can be written as number of protons or number of electrons. That means Z is equal to P or E. Mass number then is the sum of number of neutrons and number of protons. So A equals to N plus P or P plus N, that is same. P is atomic number only and number of neutrons then can be calculated as atomic mass minus atomic number. So these are the formulas that are going to be used in order to calculate number of electrons, protons and neutrons in any atom. For example, chlorine example is given here, right? So if you want to calculate its atomic number, that would be written as a subscript, right? So atomic number is proton and electron only, that is 17 and its mass is proton plus neutron, that is 35 here. So number of neutrons will be calculated as mass minus atomic number, that will come out to be 35 minus 17 as 18. So in this manner you calculate for any example. So mass number is the total number of protons and neutrons present in the nucleus. Mass number is denoted by capital A. Mass number, however, is a whole number approximation of the atomic mass calculated in atomic mass unit. Now we are going to discuss Bohr-Bury scheme, which is nothing but that how these electrons of an atom are distributed in an atom. So distribution of electrons in different shell is represented by or is known as electronic configuration. Distribution of electrons into different shells, that is orbits of an atom, was suggested by Bohr and Bury, so that is why it is known as Bohr-Bury scheme. And the following rules are followed for writing the number of electrons in different energy levels or shells. The first point is the maximum possible number of electrons in a particular shell is given by the formula 2n square, where n is the serial number of that shell or simply indicates the shell number. For example, when we are saying that first shell, that means it is 1, n equals to 1. So by applying 2n square, what you will get, that 2. So maximum electrons in K shell is 2 only. Similarly, for when n is 2, that is L shell, so you will put 2 into 2 square, so it will get 8. So maximum electrons in L shell can be 8 electrons only. So it follows 2, 8, 8, 18, 18, 32, 32 pattern if you put n in respective numbers. That's how we calculate it. So you need to remember how to find maximum number of electrons in a shell, that is those concentric rings. Closer to the nucleus is the first shell which will have 2 electrons only. Second shell then will have 8 electrons. Third shell will have 18 electrons. Okay, in this manner it follows. This is the general representatives that how you calculate the maximum number of electrons for any shell. First 2 electrons, second 8, third 18, fourth 32. Electrons are not accommodated in a given shell unless inner shells are filled. So unless the atom has many shells, right, the more the atomic number, more concentric rings will be drawn. So suppose this is the nucleus and these are multiple concentric shells. So you cannot fill this shell unless these shells are filled. That is also the point you need to remember. It follows stepwise manner. The outermost shell of an atom cannot accommodate more than 8 electrons also, even if it has the capacity to accommodate. For example, electronic configuration or arrangement in calcium having 20 electrons. See, 20 is belonging to period 3. Okay, in period 3, you will learn about periods and groups also. So when you will write its configuration, what we will write? We'll write 2, 8, 8, 2. We will not write, this is correct, we will not write 2, 8, 10. This is wrong. Although you have just learned that third shell, this is representing third shell. Third shell can have a maximum 18 electrons. So why not that follows here? So because atoms are expressed in terms of stability, and that stability is expressed in terms of 8 electrons. So if an atom's last shell, outermost shell has 8 electrons, then it is stable. So obviously more than 8 electrons are not going to be kept in the last shell. However, it is showing capacity to have maximum electrons more than 8. Even still you will not pick and keep them. So that is why there is rearrangement of configuration, and in terms of calcium, for example, or that for potassium also, you write as 2, 8, 8, 1 only for potassium. You do not write 2, 8, 9 because it will be more than octet. So that is why we don't do that. The maximum capacity of M shell is 18, but only 8 electrons are filled. M shell is your third shell. This is because of the fact that elements become stable only after acquiring the 8 electrons in the outermost shell. So they follow the octet rule. After 8 electrons they are considered stable, so they are not going to show any kind of reactivity further. The outermost shell of a chemically stable atom can accommodate maximum 8 electrons, except helium, because helium has atomic number 2 only. So it has 2 atomic number. So it achieves, it's a noble gas, it achieves its stability by having 2 electrons only, and then it is known as duplet configuration. So for rest of the element it follows octet configuration, that is having 8 electrons gives them stability when present in outermost shell. But for helium, if 2 electrons are present in its outermost shell, then also it is stable. For example, now structure of magnesium atom. Magnesium has atomic number 12 and its atomic mass is 24. So hence it will have protons 12 only and neutrons 12 only, right? By you can calculate neutrons by subtracting atomic mass and atomic number. So 24 minus 12 will give you 12 neutrons only. So it is surrounded by 12 electrons and that are allotted to different shells, and it follows the order as, see, you have learned that the first shell can have 2 electrons, right? So you will write in first shell 2, and then it can, second shell have maximum 8 electrons, so you can write 8 also in this manner. So 8 plus 2 gives you 10. Now 2 electrons are left, so you will put them in the third shell as 2 in this manner. So that's how you decide the configuration of an element also. For magnesium atom, atomic number 12, we are going to write in this manner, and this is the orbital diagram where it is showing that 2 electrons in first shell, 8 electrons in your second shell and 2 electrons in the third shell. That's how you decide the configuration. This is same written here. In lighter elements up to argon, that is atomic number 18, each inner shell is completely filled. That is just till 18. Okay, let's see. Like before argon 18, it is 17, atomic number 17 for chlorine. So you will go write 287, and for argon you are going to write this, right? So the second shell before argon in all the elements is complete, but after argon it is going to change. Each inner shell is completely filled before any electron can occupy an outer shell. However, in elements heavier than argon, more than 18 atomic number, the situation changes. Although third shell can accommodate 18 electrons, but still it follows that fourth shell begins to be filled after it has only 8 electrons. So the third shell can have 8 electrons. It cannot, while writing the configuration, it can have 8 electrons only, the third shell, but it will not exceed 8 electrons. Like for argon, when you are writing this, and then for 19 you will not write this because you have to follow octet rule. The third shell will be having 8 electrons, and then in fourth shell you will start filling. So that is the correct representation for atomic number 19. This is done to maintain the stability, that is octet rule. For example, potassium, we have just shown you the example. Orbital diagrams of atoms of first 20 elements are shown here. So from here you can easily understand and calculate the atomic numbers, protons and neutrons and atomic mass. I will show you first few examples. That's how we calculate it. For example, we have been given atomic number 3, and it is being asked that calculate all the information about this atom, that is electrons, protons, neutrons, atomic number and atomic mass. So we know atomic number represents the number of electrons and protons. So electrons are also 3, protons are also 3. Its mass, it is atomic number 3, lithium it is only, it has mass 7. So number of neutrons will be 7 minus 3, that is 4. Some of the elements masses are different that you need to remember. So in this manner you calculate. And then any other example, for example, let's take carbon, 6 atomic number. So electrons will be 6, protons will be 6, its mass is 12, it is represented by capital A, right, and atomic number as Z. So its neutrons will be 12 minus 6, that is 6. So that's how you can calculate for any number if mass and atomic number is given. So if any 3 information is given, you can easily calculate the 4th information. This is the representation for first 20 elements. Then from fluorine to sulfur, and then from chlorine to calcium. That's how you represent them. Do remember that these are shells and electrons are filled according to the configuration, like for argon 2, 8, 8. First shell has 2, second shell has 8, third shell has 8, in this manner. So the main feature for structure of atom is atoms of all the elements except hydrogen. They are made up of 3 fundamental subatomic particles, electrons, protons and neutrons. Hydrogen lacks neutrons because it has what? Mass is also 1 and atomic number is also 1. So number of neutrons will be 1 minus 1, 0. So it doesn't have any neutron. The nucleus is located at the center of the atom. It contains protons and neutrons, which accounts for total mass of the atom. Nucleus is positively charged because of the presence of protons in them. Neutron has no charge. The electrons are outside the nucleus, have negligible mass, and they revolve around in special orbits known as path or simple imaginary shells. The number of electrons in an atom is equal to number of protons, hence atom is electrically neutral always. The electrons revolve rapidly in fixed circular paths orbits around the nucleus, and they have fixed energy. These circular paths are called energy levels or shells or orbits. The atoms of different elements, they contain different numbers of electrons, protons and neutrons. So this is the chart which shows arrangement of electrons in atoms of elements having atomic number 1 to 20. So here it is representing, like for hydrogen, number of electrons, that is atomic number, protons, number of protons and electrons, mass number, proton plus neutron, number of neutrons are calculated, and distribution, that is electronic configuration. So this is a summarized chart which represent all the information about first 20 elements, and then according to that their characteristic, their nature is also decided. So those having valency is what? The combining capacity of an atom when it goes for reaction with any other atom, and it happens because of the presence of electrons in the outermost shell of an atom, that is last shell. So it is said that when an element have electrons as 1, 2 or 3 in their last shell, they have tendency to lose electrons, and then they are considered as metals. And when they have more than 3 electrons in their outermost shell, they will prefer gaining electrons, and then they are known as non-metals. And depending on that, they have different types of bonding also. Those who lose electrons show electrovalent bonding. Those who gain electrons, they show electrovalent bonding only. But for example, carbon, it has 4 outermost electron, and 4 can be lost also, can be gained also, but it requires loss of and gain of lot of energy. So that's why it prefers sharing of electrons. So that gives rise to covalent bonding. We will study about electrovalent bonds, ionic bond only, and covalent bond in ahead of this session only. So depending on that, their nature is also decided, whether there is metal or a noble gas or what. So these are up to 20 shown in this chart. So with this we will wind up the session where we have covered about structure of atom. We will deal ahead in the session about chemical bonding now. We have covered atomic structure part, that what is the structure of atom in detail, and how now bonds are formed, how atom shows reactivity. That will be dealt in chemical bonding section. Till then, revise these topics. Thank you so much.